teach you about variation. Okay? Yes, you heard me right about variation. So, what is variation? The word variation is used in different fields of study. Okay? Basically, the word variation means the change to something. Okay? What do we mean by saying that is when something has changed from the way it normally happens, then how does it affect the other? So the difference that is caused between 2 or 3 quantities is the one that we say it varies. It's because that's the difference caused. So in the field of mathematics, variation helps us to study situations. The change on one object, how does it affect the change on the other? For example, the change of the process that is taking place, either it's a production process or it is an industrial company, whatever is happening. So once there is a change of the process that is normally happening, it is likely to affect the result, either improve or reduce. Why? Because there was a change of the process. So it is, if you change the quantities that you put in the production process, so it is expected the change of the results, which can either be good or bad. So mathematics, under the topic of variation, it helps us as mathematicians to calculate how does the change which happened affect the other. To what extent has it affected? So that is basically about variation. Okay? So I say variation, change to something. Okay? Now, there is a symbol that we use to calculate variation. Okay? This symbol is the symbol for variation. We use it mostly in variation. Alright. So, symbol. Okay. That is the symbol that we use to denote the variation. So now, variation is in different types. There are basically 4 types of variation. And these are direct variation, index variation, joint variation, and partial variation. 4 types of variation. Direct variation, inverse variation, joint variation, partial variation. So these are the 4 types of variation. Now, in this video, I'm going to teach you only 2 types of variation, which is direct variation and inverse variation. So, let me write direct inverse variation. What is direct variation? What do we mean by saying direct variation? Okay, so direct variation, it means that there are two given quantities, 2 or 3 quantities that have been given. If we say they vary direct, we mean that they have direct impact. When one variable change, either by increasing, meaning also the other variable is going to increase. I gave an example of in the production company or the production process that you are taking. If you have increased the quantities that you use to produce whatever you are producing, expect also to have an increase in the product. Why? Because the inputs, things that you put there, the mixers and everything that you require to produce whatever you are producing, you have increased the quantity. So it means that also the result is going to be increased. So there are 2 things here. At the beginning of the process, the increase at the beginning of the process will result in the increase of the product in the amount of products. So it means that those 2 things, they vary directly. Okay? So they vary directly. What do I mean is that when one variable increases, by the way, we are going to use symbols or variables x, y's, and the other alphabetical letters to demonstrate what we're talking about here. So I'm saying if there is the variable x has increased than normal, then variable y, which is the product, is also likely to increase or is also going to increase because of the increase of one variable. Even the result or the other variable is going to increase. So when these things increases at the same time, we say this x and y varies directly. So even when it comes to reduction, if you reduce one variable, x, okay, you reduce the value of x, the variable x, it means that even the result is going to be reduced. So when these 2 things have direct impact on one another, we say that those 2 quantities or those 2 variables, they vary directly. Okay? Now, let's also look at the inverse kind of variation. Inverse variation. What do we mean by saying inverse variation? Okay? Or before we go further, let me give you an illustration on the direct variation. So, just an example here, if we say x varies directly as y, okay? Okay, let me say example. If I say x varies directly, it means x varies directly as y. So x varies directly as y. So this is just an illustration of the kind of the variation that we have. Okay? So this is what we mean direct variation. Now, let's look at the inverse variation. Inverse variation, it is opposite to direct variation. Inverse variation, okay, let me give you this scenario. If, imagine, it takes 10 hours for 5 people to do a certain work, okay? 5 people, it takes 5, let me say, people, it takes them 10 hours. So, 10 hours, it takes 10 hours for 5 people to do a certain work. It takes 10 hours for 5 people to finish doing a certain work. Now, what if you increase the number of people from 10, maybe for example, up to 10? How long do you think these people can do the work, provided they work at the same rate? So, when you calculate here, you find that it may be take them about 5 hours to finish the work. Okay? It may take them 5 hours. So 10 people is likely to take them 5 hours. So the increase from 5, the increase of the number of people from 5 to 10, the increase of number of people from 5 to 10, from 5 to 10 people, according to the number of hours, you are going to see that the number of hours that is going to be spent is going to be reduced. Okay? From 10 hours to 5 hours. So, in other words, when one variable is increasing, the other variable is reducing. So such kind of scenario, it is the one that is called inverse variation, because when one is increasing, the other variable is reducing. You saw from here that 10 hours, it took 10 hours for 5 people to finish the work. Now, the number of people increased. Even when you calculate, you find that it will take them approximately 5 hours if they work at the same rate as they used to work when they were 5. So, this is the denotation of the inverse kind of variation. Having looked at this, I want us to solve some examples that will help us understand these kinds of variation, direct and inversely variation. So, let's watch. Alright, this is an example. This example was gotten from 2 kinds of variation. Example 1, question 1, I got it from direct variation. The second one is from inverse variation. So, this one will help us to know how to calculate a question which is connected to direct variation. This one is going to help us to know how to calculate any question related to inverse variation. So, let's look at the solutions to this problem. Solutions. Question 1 reads as follows. Given that y varies directly with x, okay, there are 2 variables, variable y and variable x. The kind of variation here is direct variation. So, we we are told, given that y varies directly with x. We write it that way, with x. Then, and x is 1 over 3 when y is 2. So, for us to solve, we need first to create the equation. Y is equal to, the moment you change from the variation sign to equals, you introduce a constant of variation, which is k, represented by letter k. So you have y is equal to kx. This is the same thing. Now, a question from here up to the end of it, we have x 1 over 3 and y is 2. These two answers are going to help us to find the constant of variation. So, for us to find the constant of variation, as the question number 1, where they say find k, simply means find the constant variation. So, we will substitute where there is x, where there is y, we put 2 is equal to k, we don't know, and x is 1 over 3. So, we have 2 is equal to k over 3. Take note, it's over 1 again. So, for us to have a constant k here, to solve the constant a, we'll cross multiply. In other languages, other people say cross multiply. Or we introduce the reciprocals. Okay? So, we multiply this side by 3, also this side by 3. Of which other people they will say cross multiply. So we have numbers like that. Okay? So 3 and 3, we cancel it, then we have 3 times 2 is 6 equals to k. So in other words, k is equal to 6. They are asking us to find the value of k. So part 1 of the question answered. Okay? So this is how you find the constant k. This one, the missing figure. Part B says determine the equation of variation. This is the constant of variation. It is not the equation of variation. It is a constant of variation. So the equation, for us to find the equation, okay, it's B. For us to find the equation, we'll get back to our expression, which is y is equal to kx. Now that we have found the value of k, which is 6, we can now substitute y is equal to, where there is k, we introduce 6x. This is our equation of variation for this question. And it's done. Just like this, it is done. This is our equation. Okay? Now, we continue solving. Part C says, find y when x is equal to 1 over 2. We now look at the change now on the variables. At first, the number was 1 over 3, which produced, or y, which produced 1 over 3. So, 1 over 3 and 2. Now, what of the change from 1 over 3 to a new value of x, which is 1 over 2? What will be the change on y? What is the answer are we going to do? Let's see. We need to calculate as mathematicians. Okay? So, to solve the value of any variable, you use the equation, which is this one. Y is equal to 6x. Find y We are looking for y when x is 1 over 2. So what is y when x is 1 over 2? You simply substitute. So y is equal to 6 times 1, which is 6, over 2. So 6 divided by 2, the answer is 3. So we are done. So y is 3 when x is 1 over 2. That's all about it. Alright, we continue solving the other part of the question. Or question 2. This is question 1. Question 2 says, find or given that y varies inversely, the difference kind of variation now. So y varies inversely as the square root, okay, square root of n. Y varies when a variation is inversely. It means that we express it in the form of 1 over. So, given that y varies inversely as the square root of n, meaning that we say as the square root of n, inversely variation is expressed in the form of 1 over whatever you have been told. So, here comes, we say y is equal to. The moment you change the variation sign to equals, introduce a constant k. Then you multiply 1, we have 1 over n, which is, the square root of that. So we have y is equal to k over square root of n. That is the expression. Now, part A, find the equation of variation. Find the equation of variation. As solved from the test, we cannot find the equation before we find the constant variation. And what will help us to find the constant of variation are the given answers that we have here. Y is 2 when n is 6. Y is 2. K over when n is 16. We have 2 is equal to k. The square root of 16 is 4. That means that k, when we cross multiply here, k is equal to 8. And your equation is y is equal to 8 over square root of 8. This is your equation for this variation. Then we go to part B. They are saying find one when n is 64. Using this equation, y is equal to 8 over square root of n. N is 64. We want to find the value of y. So y is equal to 8 over the square root of 64. This means that 8 over the square root of 64 is 8. So 8 into 8, 1. Therefore, y is equal to 1. So y is 1 when x or when n is 64. So this is how to solve any question to do with variation direct or inverse variation. I said Y variation, the direct variation, it goes straight like that. But the inverse variation, you express it in the form of 1 over whatever you have been taught. This is the inverse kind of variation. And take note that the moment you change from the variation symbol to equal sign to create an equation, introduce a constant of variation, which is scale, then you are set to go. And you cannot find any other solvings before you know the value of the constant variation. So either they asked you to find the constant variation or they did it, but you just have to ask to find it so that it helps you to find the rest of the problems. So this is all about variation. Thank you so much. In the next videos, I'll be able to share other kinds of variation.